thank you everyone for joining us. This is our second Ask the Ambassador session. We started out the first one about a month ago where we had all three of the ambassadors from EagleDream talking about some of the recent releases from AWS and things that we thought were really important around those, and also answering a few questions from the audience. Today, it's Ask Me Anything Hour with me, Scott Weber. I'm the Vice President of Cloud Solutions at EagleDream Technologies. I'm an AWS ambassador. I've been in the program for a little over a year now. So we appreciate everybody taking time out of their day to join us. So a little bit about me. I've been practicing and aware of and doing things with AWS since about 2007 when I was at Xerox Research and first got introduced to AWS. I got very deep into it 6 years ago when I joined EagleDream Technologies to help build a healthcare data analytics platform natively inside of AWS. You can reach out to me on LinkedIn. Really easy way to look me up. I'm Scott the Cloud Guy on LinkedIn. There's my email address as well if you want to reach out to me directly at EagleDream. The other thing would be is you can hit me up on Twitter. My Twitter handle is CloudGuyScott. So feel free to reach out that way as well. But excited to talk today about some pre-submitted questions that we had and then field things from the audience. So today's topics, as the way we set up for today, was we're going to talk about data lakes, application modernization, and containerization, and I'll even make this a little bit broader, serverless at some level if we want to talk about that, because containerization and application modernization and serverless are kind of all going together, and data lakes and app modernization fit together well too today. So that was where today's main topic areas are going to be, but anybody in the attendee list, if you have general questions about AWS or other things that you want to talk about, I feel pretty secure in saying today's pretty much fair game for whatever you'd like to ask. But we did have some pre-submitted questions around these three topics. So I look forward to diving into these with everyone today. But let's talk about how do we, or how can you ask a question as we go through this, because that's the whole point of today, is to be working through the questions, and maybe you saw something that got released from AWS, maybe you're new to AWS wondering how to get started in it, maybe you got a specific question. So we want interaction from the audience. So here's the information on how to go about if a question comes to mind as we're going through this, there's really two ways. You can use the participant panel and raise your hand. And we have Courtney and somebody else from AWS, Adam, from EagleDream, going to be monitoring that, and we can promote you so that you can directly ask your question. The other way is go ahead and type it into the chat box. You just click on the chat box on the controls for Ring Central, and I've got the chat window up, so I'll see those come in. So please, we want this to be interactive. We want to hear from you guys so that you guys can get the most out of this. And we're also going to record this and put it up on YouTube. Within the next couple of days, it'll be posted. So, like I said, we had some questions that got submitted as part of the sign up. I'm going to dive into these, but as I go through these, if there's additional, if something I says prompts another question, if you have a question that you wanted to bring to the table today for discussion, please, put it into the chat or raise your hand, and we'll make sure that we get you promoted to where you can ask that question. We can have a discussion around it. So the first question that was submitted to us is around data lakes, right? And it was really around recommendations on how to transition to a data lake while continuing, to maintain your current production environment. So in other words, how do you manage this, right? How do you manage through new technology infusion into your environment? And we've helped a number of customers with this exact scenario. And data lake, there's a lot of reasons to get to data lake. So, if we step back and say data lake first, you're probably running a data warehouse today in your production environment if you're looking at transitioning to a data lake. So you're very used to, ideas of structured data, structured inbound data having to fit into a schema as it comes in, and then, structured queries on the output side to run your data warehouse today. But if you're trying to figure out how am I going to make this cutover without losing my current production functionality, there's a couple strategies that you can take around this. And it just kind of depends on what your end goals and what you're trying to achieve of the migration as well. Certainly you can look at, you can start to insert the data lake concepts at the front end. And think of it today, if you have data flowing into your data warehouse today, you could maybe in parallel put the data in both places. So we can drop the data into our new data lake construct in AWS while we're continuing to send the data into our current data warehouse today. We're going to put that data into AWS though in more of a flat file format, and I'm not really going to care about the overall structure of those data files as they arrive into Amazon S3, which is going to be the center of our universe for our data lake. Then what I can start to do is I want to look at what's going on inside my enterprise data warehouse today. What is the ETL work that's happening inside that warehouse? So what I want to start to do is migrate those same ETL transforms that are working on the raw incoming data and start to enable those same ETL workloads now inside of my data lake. So what I may start to do is pick apart at what data, and I may do it like data, maybe not to the granularity data element by data element, but maybe report by report, and say, okay, can I move this ETL workload into my data lake, let the data lake do the ETL processing, write the final data out of my enterprise data warehouse, because I probably have some sort of reporting mechanism tied to my enterprise data warehouse. And so it needs to be an iterative approach. I am not a believer in big bang at all in these types of things. The other way to start to look at this is, do you have an API layer that you're leveraging today? Is there an API around your data warehouse? Is your data warehouse outputting data to relational database, systems for transactional processing? If you're exporting that data to another environment, that can be a nice way of looking at the data lake. Start to use the data lake, let the data lake do the transforms, move that out to that transactional system. But in any case, you want to do this in a piecemeal fashion, right? Now, if you're using something like, a reporting framework, a Tableau, Cognos, Power BI, any of those, even QuickSight from Amazon, you can start to iteratively point those reports now to your data lake. If you're doing heavy analytic workloads, you're still probably going to have some sort of an enterprise data warehouse at the end of your data lake. But what's going to be different with a data lake architecture in AWS is we're not necessarily going to put all the data that we have in the data warehouse today in the data warehouse in the cloud. There's services from AWS that allow us to put our core data model only into our data warehouse while leaving large queryable files living in S3. So we'll start to pick apart those architectures as things happen. But the real goal is if we can run these things in parallel as we go, so that you're maintaining production from, I'll say, a legacy standpoint, but then once you get the data lake up to more of an MVP level, anything net new that's coming in, let's put that natively into the data lake, right? Because again, we can point our BI solutions, our visualization tools at the enterprise data warehouse that we're building out inside of AWS at the same time. It's just a different endpoint for that tool to communicate with, and our end user really won't know any difference as they're looking at their dashboards. So we'd love to dive deeper on that. If whoever posted that question would like to dive deeper or has any follow-up questions, please go ahead and ask them. But I think I'll move on to question number 2. Containers. When do you use containers, and what is this Docker thing, and what is it? So if we look back, containers have been around for about 5 or 6 years now. Docker's really been a thing, and Docker was the one that, I'll say, commercialized it to a point that it really took off. If you look back in history of things, that the idea of containers has been around for a very, very long time. The Linux operating system had concepts of containers for a long time, But it was really Docker 5 or 6 years ago that brought it to the forefront and we started to see things with like microservices and books from Heroku, like, the 12-factor application, and then O'Reilly wrote the book on, beyond the 12-factor app, where containers and this idea of microservices really came to the surface. So when do you want to use Docker or containers? We're seeing a lot of customers start to make the move towards Docker in a really, really big way. I think it's finally gained enough reception in the market. We're seeing it be used with a lot of customers that want to start to pull apart their monolithic architecture and move to a microservices architecture. Docker can be a nice stepping stone to a full-on serverless implementation using something like Lambda. Sometimes the leap to Lambda from a monolithic architecture is too much, and Docker provides that nice go-between. There are also use cases where things like function as a service or Lambda inside AWS isn't a good fit, and we still need something like a container running. So we're seeing with our customers right now on a modernization path, customers that are running .NET, framework applications on top of IaaS servers. We're seeing a lot of them start to take an interest in moving to upgrading their code bases to .NET Core 3, which then allows you to move to a Linux operating system. And the natural progression there is we're seeing them move into a Docker environment on top of AWS. Getting off of the Windows OS, even if you go from Windows OS to Linux VMs, so Windows VMs to Linux VMs, you're about a 2x cost savings by not having to pay the overhead of the Windows license. If we go to containers, because we get much more efficient usage, and we can run on top of the Fargate serverless architecture for containers inside AWS, you can gain yet further savings. So we're seeing a lot of customers, again, with this legacy .NET framework application base, looking at making this move into a Dockerized environment. Yep.
Can I ask a question?
Sure.
Where do Kubernetes come in to play here?
That's a great question, Courtney. Whenever we start talking about doing things in containers, the next question that usually comes up is, what is my orchestrator or scheduler going to be? And that's what Kubernetes is. Kubernetes is an open source scheduler. Docker has theirs, it's called Docker Swarm. Amazon has the Elastic Container Service, and they also have the Elastic Container Service for Kubernetes, EKS. Kubernetes is, again, an open source project as a scheduler. So when you run containers, you have to choose a scheduler. If you're running in the cloud, and in AWS specifically, we advise a lot of customers, if they're new to containers, really take a hard look at the Elastic Container Service. It's been out for about 5 or 6 years now. It is deeply integrated into the AWS ecosystem, has a very good security model, leveraging security groups and IAM roles. And the beautiful thing about both, either Kubernetes or ECS is we don't have to touch the underlying Docker files. Okay, so if somebody has a Docker container and you're running it on premise today, or you're running it in development, we see customers using Docker for development, but not yet for pushing it out to production. All we need to do, the scheduler choice doesn't really impact the Docker container itself. So Kubernetes, keep in mind, is Google's way of running containers at scale. We have customers that have Kubernetes knowledge, and that's great. What I try to educate our customers on is there is a pretty serious learning curve to Kubernetes. There are reasons to go to Kubernetes for sure. But we've been having a lot of success with customers of sort of just keeping it simple, getting them up to speed and running on ECS on top of Fargate inside of AWS. Now, the Elastic Kubernetes service from AWS, that will help you a lot with a lot of the heavy lifting. But there's still a lot under the hood that you need to understand from a Kubernetes perspective. But if you've been doing Kubernetes on premise and you're looking for a way to move into the cloud, certainly take a look at EKS as a way to ease your administration burden and get you into the cloud.
Thank you.
Yep, so once we've chosen our scheduler, we're off to the races on deploying things. The other areas that we're seeing containers come in is batch processing. This is a very common way of using containers. So, we queue things up, fire up a huge fleet of containers, let them chew through all that work and then tear down that fleet of containers. Moving on, this is a little bit back to data lakes, recommendation and best practices for data extraction. So one of the things, if we back up a little bit about a data lake that, excites us when we're working with our customers about data lakes is you have this idea of, in a data lake, the saying sort of goes like this: schema on read, not schema on write. So if we think about a data warehousing architecture, data warehouses have a schema in mind when the data arrives. So we have to fit data, inbound data, that data warehouse, into the schema that's already established for the data warehouse. So we're transforming data on the way in, deciding what we're going to keep or not keep of the inbound data as we want to write it into our data warehouse. When we flip this over to a data lake, okay, we want to be greedy and put all the data in the data lake. We don't really want to worry about filtering the data out, and we don't care about what format the data is when it comes in. It can be a CSV file, it can be tab delimited, it can be a Parquet file, an ORC file, XML, JSON, log files, images, audio recordings, text extracted from audio recordings. That all is fair game for putting into a data lake. So how do you do this type of data extraction? Well, let's assume for a moment we're going to pull data from an on-premise relational database engine, whether it's SQL Server or Oracle or an open source engine, or that that database could be running in the cloud as well. We have a number of tools that we can use to do that. The one sort of go-to tool is something called the Database Migration Service from AWS. And while the Database Migration Service was born as a tool to help us do heterogeneous database migrations, like from SQL Server, Oracle to Postgres, one of the things that it can do, though, is it can push data in real time or in a batch format to flat files in S3. So we can set it up just to be continually writing the changes that are happening on the source database into the S3 buckets. So that can be a really good way to pull data from an on-premise database environment. Again, we can just plug it in. Another way is to use, and we help some customers with this, where there's APIs. Maybe they're trying to extract data from a third-party system that's quote unquote closed. They can't access the underlying underlying database, but they can access the data through an API. There again, you can write a process running in Lambda or running in containers that at some interval will reach in, hit those APIs, extract that data into a flat file format, and put it into the data lake for us. From that point on, we're going to use tools like Glue to build data catalogs, Glue to do ETL transformations, Athena to do, discovery of what the data actually looks like. Then we get into the category of sometimes we need to try to do things in near real time, or we have data coming in a very fast fashion, and we don't necessarily want to write it to another intermediate place. So think social media feeds, right? So in that case, we want to use streaming technologies. So the tools that we would go to in that case are things like Kinesis, and then have Kinesis Streams feed a Kinesis Firehose. Or we can go to Apache Kafka for streaming as well. So in that case, it's a pub sub model. You have systems that are constantly feeding information into those streams. Those streams then, through something like Kinesis Firehose, will persist the data out and into S3 for us, and then we can act on the data as it arrives into those buckets. Looks like we've had a question get submitted. What types of projects are we seeing customers do for app modernization? This is a great question. We're seeing a lot of customers now that are falling into a couple categories. One, where they have a legacy monolithic application that has just piled up too much technical debt to continue to move forward with. And in those cases, a lot of the customers are like, help us understand how we can essentially hit the redo button and the reset button and do a do-over. We're helping those customers move into a cloud-first, cloud-native architecture, a lot of times landing on serverless architectures with Lambda, Aurora for databases, or DynamoDB tables for databases and data storage. We're also seeing customers that are sitting on legacy data warehouses on premise where they're typically a licensed, an Oracle or a SQL server, and they're really getting tired of the cost that comes with that, or they're getting near a hardware refresh cycle. And they're looking for a way to be more flexible, to move faster. And those customers are looking at, and I throw data lake under app modernization in this category, in this case, of how can I modernize my data processing so I can get more, meaning faster, out of all my data at a lower price point. And we've got some case studies that are going to be coming out around that of how we're helping customers in that category. The other category of app modernization we're seeing is really focusing on Microsoft workloads. And there's actually a special co-funding program from AWS right now called Microsoft Application Modernization, which is focusing on helping customers get away from having to run their .NET and SQL Server applications on proprietary OSs and proprietary databases. So in that case, that's where we're looking at moving customers from like a .NET framework or even .NET Core running on IaaS to Linux containers running on top of Fargate. Then we're helping customers, deal with the database side of that. Can we get them off of SQL Server and onto a Postgres, or if they're using an Oracle in the back end, onto a Postgres database as well? So, those are kind of the things that are fitting into our app modernization practice today. We have examples of working with customers across all three of those categories. But it is amazing as we work with these customers and we inject these new ways of thinking, these new ways of doing things into their workloads, how much money they're able to save, how much faster they're able to move, how much more reliable and redundant the applications become as they get stood up on this cloud platform.
Hey, Scott, around application modernization, is there any situation or application where modernization isn't the right path or not the right way to?
Yeah, there definitely are cases. So some of those cases, you always have to do sort of a ROI, return on investment analysis on these things. So a couple categories where app modernization doesn't make sense is if it's a third-party application that you're buying license to, obviously you're not going to modernize that, right? You may look to move to maybe a SaaS offering, so you stop running that in your data center or running it in the cloud, but you're not really going to be able to modernize that because you don't have access to the source code. But if it's an application that's been written in-house, you need to look at, one, do you have expertise in-house that knows this application? Sometimes, the app is fragile. There's concerns about touching it. I mean, those are valid concerns. But you also then have to ask the question, how long is that application going to continue to live? Because the longer it lives, the more reason there might be to rewrite that or modernize that particular application and get more control on it. If there's an application that is going to be sunsetting either through a replacement coming or offloading that to maybe a SaaS application, in the next, X amount of time, 6 months to a year, it's probably not worth taking that cost to rebuild that application. But we've been working with customers where some of these apps are absolutely core to their business. In one case, the application is the CRM system that the customer built in-house. Another case, it is the application that provides the services that this customer provides. And so in those cases, the ROI is extremely high to start to rewrite and modernize those applications. In some cases, it's a full rewrite. In some cases, it's just a move to a cloud native platform and giving some more ability for speed and things for the organization. Let's see, what other questions do we have coming in here? When do I know it's time to make the change from EC2 autoscaling to ECS and containers? Great question. So a lot of us, if we were building a workload in AWS, even probably 4 years ago, a lot of us were still defaulting to using EC2. I would say, containers hasn't really come on truly heavily until like maybe the last 3 years. And certainly a project that I helped, when I joined EagleDream 6 years ago, our healthcare data analytics application that we built natively into AWS, 6 years ago, our only option was to build that upon VMs. We used Linux VMs and the Java microservices architecture. I would say that if you're running on EC2 today and it's a home-built application, you really should start to look at, can you start to make the move to ECS and containers? chances are you're going to have lower cost. Certainly by running on top of the Fargate system, you're going to get rid of having to maintain and secure those and patch those underlying VMs. There are now tools from AWS that were just announced. One of them is called App2Container. It is a set of scripts that AWS has published as a formal service that, for a Java-based web app and like a Tomcat type of environment, will scan your code and package it up into a container for you so now you can actually run it as a Docker container. It'll even go so far as to help you start to build out the test definition file that goes with ECS or the deployment file for EKS, and start to put together the code pipelines for actually getting it deployed. We can also use that for containerizing .NET applications running under IIS to run as part of Windows containers. We don't hear a lot, but it does exist to actually run Windows applications inside Windows containers. I think we'll all be happy and excited when and if AWS can release a version of Fargate that can support Windows containers, because that's been a huge boon for everybody running Linux containers where I don't have to worry about managing my underlying VMs. But getting rid of that management overhead of the actual EC2 instances and getting to a containerized workload, it helps it alleviates a lot of different things on the business. One, if we're using the containers in development as well, we get rid of that problem of, well, it worked on my machine, I don't know why it doesn't work in production, because the container they worked with in prod or in development is exactly the thing that got deployed to production. I can tell you from past history, and I've got the scars to prove it, I've been burned more than once with that saying, or something about somebody's development environment. It wasn't exactly the same way production was, and we deployed to production and it just didn't work. The other thing to think about containers, if you have a scaled environment where you're using auto scaling of your EC2 instances, the containers will scale faster. So typically a Linux EC2 instance inside of AWS is about a 3 to 4 minute boot time before it's ready to go. That's okay, but if you have a really rapidly scaling application, container boot times are typically less than a minute. Okay, so you'll get faster scale up, potentially faster scale down. And all containers on top of the Fargate environment are billed at per second billing, which can be an attractive thing as well. So thank you for that question. Do we have any other?
Scott, I want to make sure you get to Alexander's question in the question and answer box.
Okay.
And he sent some good documentation to take a look at.
All right, I'm looking for it right now.
And for folks also in the line, I can throw it in the chat box too. And it's related to using Glue to do ETL jobs. Any advice for modifying DPU capacity to improve performance?
Yeah, actually, let me reading it through right now.
Perfect.
Okay.
And Alexander, if you have anything else to add, feel free to throw it in the chat box.
Yep. So thank you, Alexander, for this question. Our team has been doing a lot with Glue and different customers. And what I would really like to do, Alexander, is take this question back to the data scientists that have a much deeper understanding of Glue than I do. But I'll give you my high level, but we're going to take this back to Ryan and Brianna on our cloud team to get a better, deeper answer for you. And we'll make sure we get, I think we have your email address from registration, because I want to make sure we get you the best information as possible. Max needed executors, active executors, and allowed executors, but not seen a noticeable difference. Okay. So one of the things that we have to, so for those of you, listening in or watching this after the fact, let's back up for a minute about what is Glue, right? Glue is a service from AWS that essentially does two things. One, it will crawl your data as it sits in S3 or other databases and build for you a data catalog. That data catalog is very important from a data data lake perspective, because the data catalog is then what allows us to query across different sources of data. The other thing that Glue is or does is essentially it's a managed Spark implementation for you. So Spark is a Apache open source project that runs on top of Hadoop for ETL type processing. Can do a bunch of other things too, but we'll just keep it focused on the ETL for today. And it uses a derivative of Python called PySpark. And so with Glue, the whole idea of Glue is AWS helping do that undifferentiated heavy lifting for you. You don't have to worry about managing, EMR clusters, which is AWS's service for Hadoop. You don't have to worry about configuring Spark, that sort of thing. You write your Glue transform, you submit it, and behind the scenes, AWS is spinning up a Hadoop cluster with Spark pre-configured and executing those scripts that you've given it. So some of the metrics that Alexander is talking about here are the knobs that we can turn to help increase the performance overall of Glue, because again, Glue has some baseline capabilities, and then you can tune that to get more out of it. So Alexander, I'm not the expert on Glue. Again, Ryan and Brianna on our team are, and we actually have some regularly scheduled meetings with the internal Glue team at AWS. So instead of giving you erroneous information, I want to take this question back to that group and let them dig, deeper on your problem and get back to you. It looks like Brianna just in the general webinar chat has posted some information as well. So thank you for that question. Apologies, I couldn't give you a good deep answer, but we will get things resolved and work with you to help get you the information you need. Do we have any other, I'm just looking through the chat if there's any other questions that came in. Thought I saw one in here about data warehousing.
Oh, there was one related to the benefits of having a data lake feed their data warehouse.
Right. So good question. So you're like, well, if I have a data lake, what do I need a data warehouse for? So we want to think about the right hammer for the nail that we're trying to drive in, if you'll go with that analogy, or the right tool for the type of job that we're trying to do. So if we look at a data lake and the tools that we typically use around a data lake, we talked about S3 for storage of all my files. Why is S3 good? Because I've separated compute and storage, and I get a really low priced storage tier in S3. Why do I want to use Glue? Well, Glue is a managed service, so I don't have to worry about managing EMR and Hadoop and Spark. And it's sort of a pay-as-you-go or pay-as-you-run type service. We classify it as one of our serverless services because there's nothing I have to maintain. We have things like Athena as well that can basically query any of the data in the data lake, uses the Glue data catalogs to do that. But every tool has its limitation. Every tool has its sweet spot. Okay, so where things like EMR, Spark, Hadoop, Glue start to struggle is if we're doing really big, gnarly data analytic queries where we want a lot of analysis, we want numeric analysis done. Those tools can start to show their weaknesses when we get into some really big and hairy type of analytic queries. However, this is where the enterprise data warehouse usually shows its value, right? So what we work with customers is understanding that we want to do a lot of our ETL work inside of Glue and EMR and Spark, and we want to leave those big heavy-duty analytic queries to run inside our enterprise data warehouse. And the enterprise data warehouse service from AWS is called Redshift, and it is highly optimized for doing heavy analytic queries. There was some presentations at reInvent probably about 3 years ago now about Amazon.com's usage of Redshift. And in this particular use case, Amazon.com multiple times per day was running joins across multi-trillion row tables to multi-billion row tables. So think about that for a minute, okay? Multi-trillion row tables joining to multi-billion row tables, and Redshift could return that result in minutes. Which isn't too shabby, really. Now, Is Glue going to be able to do that in minutes? Probably not, right? So this is where it's choosing the right tool for the job. The difference is we are not going to take all of our data out of our data lake and put it into our data warehouse, because I'm willing to bet you don't need it all in a data warehouse. Plus, we have other tools from AWS that can extend our data warehousing concept to files still living on S3. And that was a service that came out a couple of years ago called Redshift Spectrum. So if anybody's familiar with like the idea of external tables that Oracle had, where you could have a CSV file living on a file system, but declare it as a table inside of your database and then run joins against it, this is a similar idea of Redshift Spectrum, that I can put a file, you know, typically Parquet type files, columnar, flat file storage mechanisms work best for query performance. I could put a multi-terabyte data table as a Parquet file in S3, but then have my core data warehouse model in Redshift and do joins against that data living in S3. This is an advantage because I'm not, disk and CPU are coupled on Redshift. So now I've decoupled my storage. And actually, this is the model for the new, AWS is calling it the new instance types for Redshift. I'd actually almost call it a new version of Redshift personally. It's the new RA3 instance types of Redshift. And it's a complete different architecture essentially for Redshift, that now all of the data lives in S3. The disk space that is now set up for Redshift is actually direct-attached SSDs that Redshift is caching the most frequent queries, query results, and data sets to those local SSDs to speed up querying for the most common queries. But all of the raw data is actually resident in S3. And so this is a big architectural difference now that really goes after this idea of like, you almost now have unlimited storage for your Redshift clusters, because there was actually, in theory, some limits to what Redshift could do in the past. Okay, let's see. Any other questions come in? I see Brianna's helping Alexander out, so that's great. So we'll definitely get back to him. So how can people get started down these pathways, looking at app modernization or data lakes or containerization? Start small. Honestly, do a hello world type implementation of containers, right? Take your preferred programming language, and just do the hello world exercise, but deploy it as a container, as a very simple, web front end in a container, because your development process doesn't necessarily change with containers. It's your deployment process and the deployment model and the running of your application model that changes with containers. We help and advise customers all the time on making this move from the way that they did development of just deploying things out to IaaS or deploying things out to EC2 instances to containers, is that it really should be a very small blip for your developers of how they're going to change their development processes. The bigger changes in that DevOps side of things, how your code gets deployed, how you manage the things that are deployed out. So again, go after the hello world. We touched a little bit on Lambda. Go in and just do some very simple things with Lambda. If you're going to go after Lambda and function as a service, take a language that doesn't have to be compiled. Go after Python or Node.js to get started. It's just going to be easier. You can actually write right into the console of AWS your code or copy it in for Node.js and Python. That just makes it a lot easier if you're not working with a compiled language like .NET or Java to get started. But again, do a hello world inside of Lambda functions to get started. Data lakes can be a little bit trickier to get started with. Do a little due diligence and do some reading out there to get comfortable with the concepts, the idea of what is S3, how does S3 work, how does Glue work. But maybe take something that you're currently doing in your data warehouse and just try to do that inside the data lake. I'm a very, very big believer in iteratively doing things. So start small, add complexity as you go. I love the saying that a complex system that works is actually made up of a lot of very simple processes behind the scenes. So always try to keep it simple, keep it to a small thing to get started with. And on app modernization, I think we're going to see this continue to grow and grow. All the majority of application, in-house developed applications carry with them technical debt. Sometimes that technical debt just becomes so heavy that you reach a point where, it's better just to scrap it and start over. Or sometimes you just want to do that, maybe it's you're trying to get away from those expensive OSs and databases. But from an app modernization perspective, we do a lot of work helping customers in what we call a discovery phase of looking at their whole current application architecture, talking with them on where they think they want to take it, how could we change this? But, we also spend a lot of time educating the customer. So keep eyes out for Immersion Days that are going on out there that you can attend. I know that we have 2 Immersion Days coming up in August. One is going to be a general half day on AWS. We're going to talk about AWS's global reach and EC2 and storage. And then a couple of days later, we're going to do an immersion day on data lakes. So that's a perfect way to get up to speed on data lakes. But, under the app modernization, area, start to look at how could you change things? How could you, start to leverage containers in your workflows? Look at do an ROI analysis of what does it mean if I don't have to maintain, EC2 instances anymore, or the underlying VMs, and just take it slow. You're not going to rewrite your whole application into a modernized architecture in a month. Can you section off pieces of it to take to containers first? If you already have an API-based system, can I start to take a couple of those APIs and put them into a container? It's just, where am I calling my API at? Okay. Look and see if we have any other questions. All right. Well, I think at this point we've taken up the majority of the hour. So why don't we sort of talk about what's coming next? So we have a couple more upcoming events under the heading of Ask an Ambassador. So on August 5th at 1 p.m. Eastern, we're going to have my colleague, Justin Goosey, come and talk about and field questions around cloud migration, disaster recovery, and really anything to do with Windows and AWS. I'd encourage, if you guys have Windows-based workloads and you want to understand what it means to move those into AWS, please come in and pick Justin's brain in this session. He's an expert in these areas. He's also an expert in understanding and helping customers figure out how to do DR from on-prem to the cloud or DR in the cloud. And then on August 26th at 1 p.m. Eastern, we're going to have Dustin Potter from my team come, and he's going to talk heavily about DevOps and cloud native software architectures. Data lakes are one of those things. I think you're really like talking to him, but if you're really wanting to dig deep on how does DevOps change as you go to the cloud, what does cloud native software look like, what are some common architectures, please come and ask Dustin. So I think at that, here's how you can reach out and stay connected with us at EagleDream Technologies for our latest announcements. You can follow us on Instagram, Twitter, LinkedIn, and Facebook. But really appreciate everybody's time today, and we're looking forward to future engagements.